to give you a little bit, if we did go to the garnet zone, basically the biotite that we saw that would have started to appear in the biotite zone would have reacted with a mineral called chloritoid, which is very similar to chlorite. It's very similar to chlorite, a little bit different. It's called chloritoid. Would react with the biotite. It would also react with the quartz, and that would produce your garnet. It also produces muscovite. So we're going to start seeing muscovite very large. We've seen muscovite throughout. So we skipped over that one, and now we're in the staurolite zone again. What about the rocks? What have you seen in the rocks? Steel slates and phyllites? What do you think about the rocks?
It's getting harder.
They're not
Harder
slates.
to break.
They're not slates.
They're not slates.
No. Right.
They're phyllites.
They're probably schists, getting into schists, and usually the schists too, because of the quantity of the micas in it, the schists are very, very shiny. And I think the one piece, Matt, that you had that broke off is extremely shiny, right? So think about it. You're increasing the amount of mica, larger grains of mica. So it's something that should really stand out on the rock. So we've really gotten into the schists. No staurolite. I wasn't able to find any. And again, you have to remember, staurolite's just starting to appear as we get into these zones. So maybe we'll see some in the next section where we're further along. But so the staurolite would take chlorite, and that would react with muscovite, and you would get staurolite. Also some biotite, some quartz, right? And we see, now that we're further into, we're out of the biotite zone, but we're further into the amphibolite series. These rocks, you could really see the biotite very large. You can even start to see very, very tiny pieces of garnet. The garnet are the things that look a little bit more round, and they're like a redishy brown, almost like a rusty color. You start to see more of those, right? And think about it, we should have stopped at the garnet zone. We didn't, so we're further along past the garnet zone. So it makes sense that we're seeing large biotites, little tiny garnets, and hopefully we'll see staurolites at the next thing. So these rocks really should have the coarsest grains that we've seen so far, right? And they have. You finally had things where you could pick it up and say, oh, look, that's a biotite. I can actually see a piece of biotite versus I can just see that I'm getting that shiny reflection. You could actually start to see it. You could actually see with your eye, gosh, I think that's garnet. I think that little reddish colored speck is probably from the garnet that we're seeing here. So what we're going to do is we're going to make our way to the last, well, to stop 8. I think stop 9 is the last one. We're going to go into the silmonite zone, which is essentially the last zone in the amphibolite series. You're going to see extremely coarse garnets. You're going to get to see the garnets. Lots of muscovite. Maybe we'll get to see some staurolite. If you want to collect a sample that's going to look nice sitting on your desk, then people are going to say, ooh, what's that? And say, oh, collect this sample. These are the ones you're going to want to collect.
And what zone is it you said?
We're going into the silmonite zone. Sillimanite. What happened?
No, the car.
That sounds hard.
So that's our last. We've made really good time. I mean, so it's almost 1 o'clock.
Yeah, we're pretty smart.
We'll probably be back by 3-ish, I guess. By the time we get from here, and then we have to drive back. But that'll be our last stop. Do you guys have questions, presentation stuff, anything you can think of at these sites?
How would you volley back to us if we were presenting? Like, what would you be asking?
I would be asking you, I'd want to know the whole overview.
Yeah.
I'd want to know the whole idea about how did this form? It's part of the taconic region. Well, what formed the taconic? Regional metamorphism, right? So kind of that whole big picture. And then I would just want to see that you have an understanding of not only, well, I went to these stops and here's the rocks I found, but that you understand why the sequence is changing, some of the reactions that I've given you. This is a good spot because we actually see this progression in metamorphism. So you can talk about, well, these minerals wind up reacting under metamorphism and forming this, and that's when we see it. I think those are key things for this trip, to kind of talk about some of those reactions. Just the idea that you're seeing the change in the rock type itself, the change in the mineralogy itself. Those are some of the probably the big things. You know, I would want you to be presenting when you're up there. It shows that you get it. You get what the metamorphism is. You get how you see the sequence. Here it is. Start to be able to, in your samples, in your pictures, with your hand samples and your thin sections, pick out some of those minerals so you can show people, look, here were the rocks from the chlorite zone and the biotite zone. Can't really see anything. And then look, we head over here to the sillimanite zone, and here's the barnett, and here's the biotite, and here's the muscovite. Be able to very easily ID your minerals, things like that. So you guys have a lot in terms of really the field stuff, the field site, because you have multiple stops. Everybody else is one stop, one place. So you have a lot you need to convey in the same amount of time that they're conveying. This is the Palisade Sill, which obviously is different as well, but you have a bigger picture kind of to look at, a much bigger regional picture. So you have to get that across, and especially if you're giving a talk, you have to get that across in 10 minutes, I think I said you have, same as a conference, 12 minutes? 12 minutes with 3 for questions?
Yep.
Okay, so that's not a lot of time to get all this stuff together, so you have to be on point, you have to be technical. You don't want to spend a lot of time. You don't want to spend a lot of time talking about the basic stuff. Like what is metamorphism? You want to jump in there saying, "Well, you should know what that is," and this is the technical. This is the good stuff. This is the nuts and bolts of everything. That's what we're looking for. All right.
It's
You
not
ready?
even your topic.
No, it's not.
Okay.
Oh, I just was wondering.
Which one is yours?
Sterling Hill Mine.
Sterling Hill. I mean, you're in one spot, but you've got a lot of just neat stuff going on. Very, just very unique. You know?
Yeah, definitely the fluorescence was really neat.
Right. So you want to focus on kind of explaining
Why
what a
it
big deal
happens.
that uniqueness
Yeah.
is. Yeah, why
Yeah,
the
why it
fluorescence is
happens.
happening.
How it's formed,
Right.
I guess.
The number of different minerals that have come out of just that one
Yeah,
area.
I have that written down.
You know.
A lot.
27?
How much?
I don't know. It was,
Yeah, it was
something a lot.
Yeah.
Yeah, so you're going to want to focus on that because that's super unique, So each spot has very unique things. This one just has a lot of places that you need to account for. Anything else?
Let me see
Matt,
that.
where's my Sharpie marker?
It's in your trunk.
Oh. That's my soil people. I'm very worried about my Sharpies. Okay, anybody need bags before